Picking up where we left off on the introduction here, there's a little bit of pitting here on the chassis, but nothing that's substantial. I think it'll clean up good. You can see I've got some wipes out here, and I'll continue wiping this down in just a bit. But let me flip this back over here and let's take a closer look at the underneath side. I took some time here, got the shop vac out, cleaned up some cobwebs and other remaining particles here that were underneath the chassis, but this thing looks remarkable. In great condition considering its age, and it looks like it's got all original components except for a handful here. This is taped in, not sure if that was from the factory or not, but you can see I do have the original Zenith paper caps in, and it looks like for the most part I've got the dog bone resistors with the exception of this one right here. Here's what I was going to point out. It was interesting, this lead has been cut coming out of the power supply section. So let's remove these two fasteners and two on the side here and see what's going on here in this area. Okay, this should just slide off now. And there we have it. Let me reposition the camera here so we can take a closer look at the power supply section here. You can see all the capacitors here, and see if we can determine what's going on here. And I'm not certain what's going on here. A lot of tar-like material here on the looks like the bottom side or top side of a transformer, which I believe this would be the choke itself. Well, I may have spoke too soon, saying no one had worked on the receiver at some point in time, but you can see this lead is cut, and then it's probably not showing up on camera, but over here maybe the other ends of the lead it's cut. And what's interesting is this raised area right here. I can't tell if that's by design or not, but that looks like that goes back to the electrolytic can itself. So my guess is this is one of the electrolytic leads that goes back to the electrolytic that's mounted on top of the chassis itself. And you can see the other capacitors that are in here as well that tie back to the synchronous vibrator here also. Let me pull this lead out right here and see if we can get a closer look at things here. I'm going to just go ahead and cut it back here and get it out of the way. See if I can pull some of this back here without creating any harm, and see if we can identify this lead right here. I tell you, it's tight. It's amazing how much stuff they're able to kind of pack in these things. You've got 1, 2, 3, 4, 5, 6 capacitors. What I believe to be the choke itself, and then, as I mentioned, you've got the capacitor on top as well. And it may be that this capacitor here, somebody stuffed it underneath, and it's actually to replace the capacitor that was on top, and somebody put it here, left the top one mounted for aesthetic purposes. But we'll check the schematic and see if this unit actually belongs here or not. You can see it's a sprag, and that's why it's kind of a giveaway. In my opinion, this would not be original. These most likely are, and you can see this paper cap here. I don't see the Zenith on it as well. So I'm still not absolutely sure where this lead goes, but I'll break all this apart if I need to and just remove this plate where we can get back in here and take a closer look at things. The tar here on the outside of the choke is quite interesting. We'll look at it and check the inductance as well as the DC resistance, and have that for our documentation, and we'll make sure it's good. But I thought first this was a raised up area. This looks to be just a solder 2 location with some lugs on it. You can see this is a ground location, and then this is just a tie point for these capacitors and the choke itself, it appears. And underneath that resides the electrolytic that's mounted on top of the chassis itself. Of course, we'll spend some additional time here in the power supply section for sure, as all these electrolytics will need to be replaced. One thing that's interesting, you'll see the DC input here to the switch. The output here routes back over this black conductor right here, ties into this terminal strip, and then this solder connection right here goes back down to a tube socket, and that tube socket itself is being used for the synchronous vibrator that I mentioned. So I'm going to flip this back over, stuff this back in for now. I'll just leave the top cover off, and let me see how the synchronous vibrator here is attached to the chassis itself. I'd like to go ahead and just pull it out for now, and maybe we can do a closer examination on it. Same drill here. Looks like I can just use my 1/4 inch nut driver here and remove these 2 fasteners. And if I'm looking at this correctly, underneath the can itself should be the synchronous vibrator that I mentioned, and we should be able to remove it at this point. You guys can take a close look at that. Hopefully that's showing up on camera. Interesting. All this cardboard material, probably just to cut down on the noise itself. And this appears to be the original Zenith vibrator that was put in back in the day. This part number is called out on the schematic, so we'll reference that just to make certain. Again, best I can tell, this resides in a tube socket, so let me see if it will actually we can just remove it here, and we can. And you can see it is keyed, and that does match the original documentation, the 190-6. Let me clean up around here, and we'll decide here what's next. I'll probably just go ahead and get these remaining tubes out and get them to the side, just so we don't create any problems. This one looks like it's broke from the grid cap itself anyway. See if I can get those removed and just document what's in there, just to ensure we have the right tube in the right location. The grid lead itself attaches back here, and you can see this grid cap is loose from the tube. I'm not sure if we've lost vacuum or not. We'll test this tube on the tube tester at some point during the restoration. There we go. Let me go ahead and remove these others and just document the my findings here against the schematic itself. See what we have. What I did to remove the remaining grid leads here was just expand the connection point here, and then just push down on the grid cap itself that's attached to the tube, and just have it release. You can see how these particular connections here are soldered on, and how they're made here to affix themselves to the grid cap of the tube. Let me pull the tubes out here and see if they're all original Zenith tubes. And sometimes you'll find that the chassis itself, or the tube sockets, are labeled, just in the case as this here, where it's listed as Vib for the vibrator itself. There we go. So it is an original Zenith tube, and it's a type 38. Indeed, the tube sockets themselves here are also earmarked, or at least this one is, with the tube, and I think the 38 is a output tube, and that grid is definitely loose, but we'll test it. We can use some super glue and get this back down on there, possibly, and salvage this tube. The base is nice and secure here. The tube shield here is one that's attached that you just rotate in a counterclockwise position and just pull it straight up. You can see it's also keyed in how it attaches here. Alright, and this tube socket's labeled as well. Looks like a, what, 6 T7? Yep. And that's what we have here. A 6 T7G. That's showing up on camera. So we're 2 for 2, and that's a Zenith tube as well. And I don't think this is going to be the original tube, but we'll see. You can see what's called out, at least on the tube socket, is a 6D8, 6 Delta 8, and what I have in here looks like a 6 Alpha 8, 6A8. As you can see here, that's showing up with the glare. We'll see if that's a cross-reference here. And the first tube here that's not the original, not the Zenith tube. And I'm not sure this is the original tube shield or not. I'll have to look at some photos of some other restorations. But it does seem to sit down on there fairly tight, so I'm not certain that that would provide the correct shield. And it looks like it is keyed, so this is probably one that was added after the fact, and the original may have been misplaced. Let's see. That would be my guess at this point. Again, I'm only putting pressure on the outside edge here, not to put pressure on the tube socket itself. And I don't want to apply too much pressure. I can't tell you, I've cracked or broke tube sockets in the past trying to wiggle these things out. This one is glued in there also. Alright, feels like it's starting to come here. There we go. And it calls out on the tube socket here a 6S7, and that's what we have installed, is a 6S7G, and you can see there again it's a Zenith tube, so it could be one of the original tubes for that time. Alright, you can see now a better look at the chassis itself. This thing, it looks fairly good. Just a little bit of surface rust on some of the fasteners that come through. The tuning condenser, I did notice, is seized up to a point. Well, there it's moving now, but it's kind of skipping a beat there, you can see. So we'll take it out, de-rust it, get everything lubricated and get it back in as well. Looks like a little desoldering here to get this little trimmer or patter off here that's used as a adjustment here. And then soon, in a future video, we'll take a look at this particular synchronous vibrator and see if we can determine if it's actually functional or not. Because at some point during the restoration we'll need our high voltage to the plates, of course, of the tubes. The 6 volt simple enough, but we'll look and see if we can actually get anything out of this thing and keep it original. If not, we'll look to do a simple modification, unless I can put my hands on a replacement synchronous vibrator. Thanks again for watching, folks. More to come soon.